Hi guys. So what I want to talk about is random variables, expected values, and standard deviations. So three pretty big topics inside of our random variables unit. So to try and speed things up, I have worked through a little bit of the problems beforehand. If you want to see any of the specific calculations, feel free to pause the video at any time to kind of see what I wrote. So let's start with the idea of what a random variable is, and then we'll get into the other two topics. So set up a very basic example here. I say I have a carnival has a duck pond game where you pull a duck out of the pond and the dollar amount written on the bottom of the duck is the amount of money you win. The probability model below represents the random variables. So probability model is just a way that we can organize and represent our random variable and how it relates to probabilities. Okay, so it's kind of a table format for representing probabilities. A random variable, so what I have here is in my top row, I have x equals money won. This, x, is our random variable, okay? So we have a random chance of winning $0, winning $5, and winning $20, because that is the money won. So a random variable in this case is some sort of variable that is tied to a probability. There is a probability that we win $0. There is a probability that we win $5. There's a probability that we win $20. There is probability tied to the idea of how much money we win in this carnival game. The second row says P of X. So this is just the P represents probability of X, this variable we just defined as money won. So this is the probability that you win these different values. So right below 0 is 0.8. So there's an 80% chance that you win $0. Right below 5 is 0.15. So there's a 15% chance you win $5. And right below 20, there's 0.05, which is a 5% chance you win $20. That's what a random variable is. So once you have your random variable in your probability model, we can talk about calculating an expected value. Okay, so we could talk about an expected value, which is the same as a mean. So I represent this by mu, and then I have a subscript of x because I'm finding the mean or the average of this variable x, which was what we defined up above. Another way I could say this is instead of mu of x, I can call it e of x for expected value. Now the formula that you get for this is the summation of xi times pi. What this means is you're going to take each x value, times it by p, add it to the next one. X times P, add it to the next one. X times P, add it to the next one. X times P, so on and so forth. So I've kind of already done that in this problem. I took 0 times 0.8, add it to the next one. 5 times 0.15, add it to the next one. 20 times 0.05. And then if there was more to my probability model, I would keep adding it up. Be very careful when you type that in the calculator. If you do this correctly, you should get 1.75. So let's talk about what that means. So when you're talking about an expected value, yes, we are talking about means, which people are like, oh, that's an average. So some people would be like, oh, so if I play this game, I should expect to win $1.75, because it's 1.75, we're talking about dollars. Well, if you look at this game, it's not possible to win $1.75. You're either going to win nothing, you're going to win $5, or you're going to win $20. So it's not possible if I went and played this game to go and win $1.75. Instead, what this means is, let's say we played this game over and over and over again. I went and played, I won some money. Reset the game. Went and played, didn't win some money. Reset the game. And I just play this game over and over and over again. So from many plays of the game, the average winnings is $1.75. So if me and an infinite amount of my friends all went to play this carnival game, and then I found the average of all of our winnings, well, on average, we're going to win $1.75. That's kind of what that means there. The final thing I'm going to talk about is a standard deviation. Now, here's the trick before I jump into this. Here's the trick with standard deviations with random variables. A lot of what we do starts with variances first, and then we go to standard deviations. We start with variances first, and then we go to standard deviations. So how I represent that is sigma squared is a variance. Sigma squared is a variance. So I have sigma squared with a subscript of x. So I'm finding the variance of this variable x, which I could also represent that as var x. Now the formula here is a summation of xi minus mu, square it, times pi. Okay, what this means is I'm going to take the individual x value, subtract off my mean, which is what I calculated down here, square it times p. Go to the next one. Take the individual x value, subtract off the mean, square it times p. Go to the next one. Take the individual x value, subtract the mean, square it times p. Okay? So I worked all of this out for us. I took the individual x value, which was 0, subtract off our mean of 1.75. Notice we had to do this first before we did a variance. If you don't know your mean, guess what? You can't do a variance yet. So 0 minus 1.75, square it, times our p-value, plus the next one. 5 minus 1.75, square it, times p. Next one. 20 minus 1.75, square it, times p. Be very, very careful when you type that in a calculator. Very, very easy to mess up, especially for a much, much bigger probability model. The value I got is 20.6875. Now this represents the variance of our random variable, which variance is nice, but this would be, remember we're talking about money, this would be like dollars squared. So variance is trying to talk about how spread out the data is. The issue is this would be represented as dollars squared, which a little bit tough to conceptualize that idea. That's why we like standard deviation much better. So we need to go from a variance down to a standard deviation. So just a plain old sigma, no square, of our random variable x. So sigma of x, this says standard deviation of x. To go from a variance to a standard deviation, just take a square root of your variance, and that is going to take your units down to, instead of being squared, singular. So my standard deviation is $4.55. Okay, and that was a quick overview on random variables, expected values, and standard deviations.